Welcome back. This is section 1.4, Errors and Warnings. In this short video, you will learn to read compiler messages, tell the different kinds apart, and fix them one at a time. Your program will not compile. That is normal. Even expert C programmers do not get it right the first time. The real skill is not making zero mistakes. It is reading the message, naming the problem, and fixing it fast. Let's learn how. Here is the plan for this video. First, we look at where errors happen. There are two stages that can report problems: the compiler stage and the linker stage. Next, we cover compiler errors. These are syntax mistakes, and you will learn how to read an error message. Then we look at linker errors. You will see what they are and how they differ from compiler errors. After that, we talk about warnings. You will turn on a broad set of common warnings with the -W all flag and learn why you should never ignore them. Finally, we build a working method. Fix one error, recompile, and always read the messages from the top first. This picture shows three things that can happen when you compile. The compiler reads your code and checks its grammar. First, the compiler error. This stops the build. Syntax errors are the most common kind. Second, a warning. The code is valid but looks suspicious. The build continues. Third, a linker error. This appears after compiling succeeds, when the linker cannot find something you used. Let's look at each one. A syntax error means you broke C's grammar rules. Common causes are a missing semicolon, an unmatched brace, or a misspelled keyword. This program is missing a semicolon after the printf call. When you compile it, GCC says hello.c, line 5, column 5, error, expected semicolon before return. Let's break down that message part by part. Hello.c is the file that contains the error. 5:5 means line 5, column 5. The word error means this is fatal. Compiling stops. An expected semicolon before return tells you what the compiler wanted and what it found instead. Notice the compiler points to line 5, but the missing semicolon is really on line 4. The rule, when a message does not fit its line, check the line above. Not all compiler errors are syntax errors. Some come from using the language wrongly, even when the structure is valid. A compiler error is any error during compiling that stops object code from being made. For example, misspell printf as PRIT and FGCC says, implicit declaration of function printf. Did you mean printf? That is helpful. GCC even suggests the right spelling, and this time the error is on the correct line because printf simply does not exist. A linker error happens after compiling succeeds. The linker cannot find a function or symbol that your code used. The message usually says, undefined reference. The compiler turns your code into object code and in-between binary form. The linker then joins that with library code to build the final program. Here, the line void greet void tells the compiler that some function named greet exists somewhere, so the call in main is valid and compiling succeeds, but the linker cannot find greet. It says, undefined reference to greet, and LD returned one exit status. LD is the linker and it failed. How do you tell a compiler error from a linker error? 3 reliable clues. The format. Compiler errors show file, line, column, then error. Linker errors say undefined reference to a name. What they mention. Compiler errors talk about the code structure. Linker errors talk about function or symbol names. And the program. Compiler errors come from CC1 or GCC itself. Linker errors come from LD, the linker, or collect2. The fix is different for each, so the difference matters. A warning is the compiler saying, this code is valid, but something looks wrong. The program still compiles. The program still runs. But a warning often points at a bug that will bite you later. By default, GCC hides many warnings. To see them, add the -WALL flag. The name means warn all. It does not turn on every warning, but it turns on the most useful ones. Look at this program. It compiles with no errors. It declares an int called count, but never uses it. Compile it normally and you get silence. No errors, no warnings. Now compile with -WALL and GCC says, warning, unused variable count. Without -WALL, the compiler stays quiet about it. In a 6-line program, this is harmless. But in a big program, an unused variable may mean you forgot something. The -WALL flag checks for much more than unused variables. -W, unused variable, catches variables you declare but never use. -W format catches print format specifiers that do not match their values. -W return type catches functions that should return a value but do not. For every program in this book, compile with -WALL. Make it your default. Professional projects go further. The Linux kernel builds with -WALL and treats many warnings as errors, turning them into a hard stop. Let's practice reading 4 messages without seeing the source code. Message A, expected closing brace at end of input. This is a syntax error. Some opening brace has no match. Message B, expected closing parenthesis before semicolon. Also a syntax error. A print call is missing its closing parenthesis. Message C, undefined reference to greet. This is a linker error. The function greet was called but never defined. Message D, warning, unused variable X. This is just a warning. The program still compiles, but the variable is never used. Now let's make 3 different errors one at a time. We compile each version, read the message, name it, and fix it. Error 1, a missing semicolon. It gives expected semicolon before return. That is a syntax error. Fix it by adding the semicolon. Error 2, misspelling printf as PRITNF. It gives implicit declaration of function printf. That is a compiler error. Fix the spelling. Error 3, removing hash include. On newer compilers it is an error. On older GCC it is a warning plus a build. Add hash include stdio.h back. Each error had a different cause, but the workflow was the same. Read, classify, fix, recompile. This program is missing one open brace after int main void. Compiling it gives several cascading error messages, and the exact number varies by compiler. But there is only one real problem. Add the missing brace, and they all disappear. So the workflow is, read the first error message, fix that one problem, recompile, and repeat until the code is clean. This works because later errors often cascade from the first one. A common mistake now. The compiler reports 12 errors, and you scroll to the bottom to fix the last one. The problem, later errors are often just effects of the first one. A missing brace on line 4 can cause errors on lines 5, 6, 7, and 12. Fixing line 12 does nothing if the real problem is on line 4. So always read and fix the first error message, then recompile. Many later errors will vanish on their own. One more common mistake. You think it is just a warning the program works. But warnings often flag undefined behavior. That means code the C standard does not define, so it may work today but crash tomorrow on a different machine or with a different compiler. An unused variable is harmless. A format mismatch in print is not. It can quietly corrupt data or crash. So always compile with -wall. Treat every warning as a bug until you are sure it is safe. Let's recap the whole chapter. Compiler errors stop the build during translation. Syntax errors are the most common kind. Linker errors appear after compiling, when a reference cannot be resolved. Warnings do not stop the build, but they flag suspicious code. Most compiler error messages have 4 parts: file, line, severity, and description. Always fix the first error, then recompile. And compile with -w all by default. That completes Chapter 1. You now have a working toolchain, and you can write, compile, and debug a C program.